Clocks on posts became popular fixtures in town squares during the 1800s. Railways were spreading fast, and these public clocks helped people get to their trains on time. Today, post clocks are often designed to look like they're from the past, but the technology that goes into making them is actually very up to date. It all starts with what's called a transfer sheet. A worker positions it over an aluminum disc that'll become the clock's dial. She removes the sheet, sprays on a chemical, and repositions it. The chemical will act as a release agent, detaching the vinyl numbers from the sheet so that they transfer and stick to the dial. She then peels the sheet off. This worker prepares a more elaborate model with numerals in 23-karat gold leaf. After coating them in glue, she applies a hair-thin sheet of gold. Then she gently brushes the gold onto the numeral. Using a computer-guided cutter, workers cut a half-centimeter thick sheet of aluminum into a clock hand that's nearly a meter long. To boost the hand's rigidity, they crease it in a press. This structurally reinforces the metal, helping retain the hand's shape over time. A 42.5-gram counterweight will balance the hand when it rotates. Here, a welder builds the post by fusing a base and column made of cast aluminum. On another model, workers attach the housing for the clock head. This clock will have 4 dials. Other models have 2. In the paint shop, workers give the base, column, and head 4 coats of paint. After applying some lubricant on a steel shaft, called a stud, a worker installs one of the clock's 8 brass gears. Brass because it's strong and durable. A steel loop called a snap ring holds each gear in place. One gear has what's called a vane to regulate the pulsing of the gears. Next, a worker attaches the shaft and gear that'll control the minute hand. Altogether, the gears form what's called the clock movement. He screws on a brass panel called a backplate to hold the clock movement in place. Then he attaches an electronic circuit board that'll later connect the clock movement to another component. He installs a 115-volt motor to supply the clock's electric power. Finally, he connects power wires and turns on the clock movement. Here, he's checking to see that everything's properly linked and that the gears are moving well. This company makes clock movements for clocks ranging in diameter from just 22 centimeters to more than 9 meters. The gears in the largest clock are nearly a meter wide. Here you can see how the shaft that'll hold the minute hand revolves inside what's called the sleeve of the hour hand. A worker attaches the clock movement to the back of a dial. Then he ties wires through what are called glass standoffs. These standoffs will cradle the clock's neon light. The neon tube encircles the clock's perimeter. It attaches through holes to a transformer hidden behind the dial. He fastens the tube with rust-resistant copper wires. Next come the hour and minute hands, now painted black. He uses an Allen wrench to attach them to what's called the hand hub. This hub holds the hands on the shaft that's part of the clock movement. The assembled dial now goes into its casing. The casing has 2 parts: an aluminum ring, called a bezel, around a glass cover known as a crystal. He connects a wire to link the dials so that they'll move in sync. The worker then inserts this casing into what will be a 2-dial post clock. Workers then turn on the neon clock light to test it. Once the post clock's installed, a built-in sensor turns the light on at dusk and off at dawn. Inside every clock is a controller that sets the time. It's linked to a satellite through a global positioning system. The GPS tells the satellite where the clock's located to set the correct local time. After starting up, the controller takes 6 minutes to adjust the hands to the exact time, which is determined by an international observatory in Greenwich, England. This company's post clocks can stand more than 6 meters high and cost up to $35,000, lending a whole new meaning to the phrase, time is money.